Hi everyone, welcome back to yet another video of the C++ series. From this video onwards, we are going to understand the object-oriented perspectives of C++, and this is the main reason why Journey started building the C++ to bring the object-oriented features inside the C programming language. Now, why the object-oriented programming became so much important that it was necessary to bring such kind of programming practices or approaches to our modern day programming. So before understanding that, let us understand what actually is object-oriented programming. Object-oriented programming is actually a programming methodology which deals with the real-life entities that exists in real world. It helps us to make or have a view of our code as a real-world entity. It revolves around the concept of classes and object. Now, what are actually classes and object? Now, class is a real world entity that exists in real world. Suppose, for example, take an example of a car. A car can be a class. Okay. Now, a class can have various properties. What are those properties? A car can have 4 wheels or 3 wheels, right? They can differ by the number of wheels. Okay. A car can have 4 gears also, 6 gears also, right? A car can have petrol engine, or you can also have a diesel engine, or it can be an EV also. A car can have a different chassis. A car can have different engines of different horsepower, right? A car can be 4-wheel drive or back-wheel drive. So what I'm trying to explain is that a car can have various n number of properties which can distinguish a specific car from another specific car. Now, Maruti 800 is an object. Why I'm calling Maruti 800 as an object? We all know that Maruti 800 is a car. Now, Toyota, Suzuki, Maruti, they are some sort of car. Right? Now, why I am calling Maruti, Suzuki, Toyota as objects? Why? Because Maruti, Suzuki, Toyota are all an instance of a class, and so they are called an object. What do I mean with this? When a car is from a Maruti brand, it has these features and comes with this chassis. This car becomes a Maruti car and it has a physical existence. So when you create an instance of a car with some specific properties assigned to it, that becomes an object. Okay, why Toyota is a car? Why Toyota is an object? A Toyota is an object of a class. See, a car class can have a bare minimum necessity of having 4 wheels. It can move, it can come back, it has to have a gear, it has to have some petrol or EV or some diesel like things. But Toyota, what did they do? They made some modification in their engine so to make it much more efficient. So these are the modifications made by the company Toyota for a specific car. But the car remains as it is. A car is made to move. Car is made to locomote, right? So the basic functionality of the car is preserved, and by adding or modifying those properties, we are making the object. So if you come to the definition of object-oriented programming, it says that object-oriented programming is a methodology or a paradigm to approach the software development in today's world. So what happens with that is, once we create an object or a class, so once we understand the definition of object-oriented programming, it says that object-oriented programming is a programming methodology or a paradigm for software development which deals with the concept of classes and object, or which revolves around the concept of classes and object. What is class? Class is actually an entity which exists in real world. It can be a human being, it can be a student, it can be a house, it can be a car, like this. So class is a real world entity which exists in real world, and objects are the instance of the class. So you can call class as a blueprint from which objects are created. So when an object for a specific class is created, the class is said to be existing. Otherwise, if we are only defining the class, it makes no sense until and unless we create an object out of it. Okay, so that's enough theory for understanding the concept of class and object and about object-oriented programming. Now, let us go to our code editor and we will find out how can we declare classes and objects in C++. So let's go to our code editor and we will find out how can we declare classes and objects in C++. So let's go to our code editor. So we are in our code editor. So here are many things which are done. So I will remove everything. We just need a boilerplate code for our main method. So for declaring a class, we use the keyword class and a class name. Suppose we are making a class of rectangle. Okay, class rectangle. Now this rectangle has various properties. A rectangle can have length and have a breadth as two of its properties, which can make two rectangles different from each other, right? So the two properties are length and breadth. I am assuming that my rectangle is going to have integer type of length and integer type of breadth. Okay, so these are the data members or the properties which differentiate a rectangle from each other. Okay, so this was about the rectangle. Now the question comes here, so I have to put a semicolon over here, okay, otherwise it will show an error. Now a question comes here, how can you create an object of rectangle class? So to create an object of rectangle class, we will come to the main method. We will write the class name rectangle, say, and write the object name. Suppose the object name is R1. Done. So we are done creating an object R1 for the class rectangle. Right. Now I want to declare a rectangle or initialize a rectangle and assign some values to this length and breadth. So how we will do it? Now if you directly try to assign value to this length and breadth, you cannot do this because these members are private to a class. Now what is private, what is public, we will come to that in some other videos, but keep in mind that you cannot access this length and breadth directly from the main functions. So for altering these values or to make changes to these values, you have to write a separate function which will assign value to this length and breadth. So for this, I will write a function, say void set values. Okay, and inside this, I will take two parameters as input, say int L and int V as breadth. So I will write length equal to L and breadth equal to V. So with the help of this function, I can assign value to length and breadth. But here there is a problem. Now once you declare a function inside this class rectangle, that function also becomes private by default. That means you cannot access the function outside the class. Now to make this function accessible outside the class, we have to declare it to be public by writing the public keyword. Now everything which comes after this public keyword becomes public and it can be accessed outside the class. See, I can also expose this length and breadth as public by keeping it under the keyword public, but it is not a good practice of exposing the data members. Rather than, it is better to use some functions to alter their values. There is also another way of assigning values to this length and breadth using constructors. We will come up to that constructor concept in some other videos. But up to now, it's important that we use this function to set the values to the particular rectangle. So how do we assign or call this set value function to assign some value to this? So we will simply write R1, which is the object name, dot, and if you press set value, the function gets called. Now the function is expecting some sort of values from us. So what will be the values to the length and breadth? So we have to assign it from this as an actual parameter. Suppose I want the length to be of 10 and the breadth to be of 20. Okay, so I am making a rectangle whose length is 10 and breadth is 20. As good as that. So this was how we can create a rectangle object and we can assign value to it using a function. Okay. Now once we have set the value, suppose we need a functionality of the rectangle to give us the area and the perimeter of the rectangle which we just created. So for it we want to define a function. So I can define a function to be as int area because it is going to return some area. Okay, so we are setting the return type to be of integer type, and similarly it will not accept any length or breadth as parameter because we are already setting this using the set value, right? So we will simply return length length into breadth. So when I call this function area, our length and breadth will get returned. So I can call just r1.area, and since it's returning the value instead of directly printing it, I would like to store it somewhere here. So int area equal to r1.area. So once this is done, we can print out, or we can just console log the area of the rectangle which we created. So we can write rectangle area is this. So 8. Now once we run it, we are expected to get some output on the screen, and as you can see, the rectangle area is 200. Why? Because we are supplying the length as 10 over here and breadth as 20. So 10 multiplied by 20 gives me 200 as the area. So as simple as that. Now this was one way of creating objects in C++. Now there is also another way of creating objects in C++ using the new keyword. Let us see how can we create objects in C++ with the help of that new keyword. Okay, so for that let me comment out this part, and we'll achieve the same functionality when we can create objects of a rectangle class using the new keyword. And what is the use of the new keyword? With the help of the new keyword, we are creating the object in the heap section of the memory. In the memory, there are two sections. One is the heap section and another is the stack section. So stack section can be accessed directly, but for accessing the heap section, you need to request permission from the operating system. So for doing it, we use the new keyword, right? So we have to write like this. So rectangle r1 equal to new, okay, then rectangle. Now once this is done, our rectangle object will be created. Okay, now since here we are using new keyword, so it is expected to give me some sort of address. So for storing that address, I need a pointer. So I need a pointer of class rectangle type. So let's put a star, and our error is gone. So now we are storing the address pointed by the R1 rectangle which is stored in the heap. Now with this, I would like to assign some value to the rectangle class. So for it, I will write like R1 dot, or you can say the arrow mark. First we'll set the values of the rectangle, set 10 and 20, and then we are storing the area by r1.area, and then we are simply printing out the area as we have done. So this is the same way how the rectangle object can be created using the new keyword, but in this case we are creating it in the heap section of the memory. So as you can see, I'm getting the same output, which is 200. So this is getting created in the heap section, and this portion is getting created in the stack section of the memory. So in this way, we can create classes and also objects of the type classes, specific classes, and we can play around with them. Now remember, a class do not get any sort of memory allocated to it by default. It is only when a particular object of a specific class is created, some sort of memory gets allocated to a class, right? A class has no physical instance or existence. It is only when an object of a specific class gets created, the particular memory allocation is done to a specific class, right? So how much will be the memory allocation for a specific class? So the memory allocation for a specific class depends on the size of the private data members present in them. So as you can see, the data members present over here is length and breadth, and both are of integer data type. So if you do a cout of size of this class R1 rectangle, so you will get a size of 8 because both the integer takes 4 bytes, and on adding them we get 8 bytes. So it is only when an object of a specific class gets created, some amount of space gets allocated for that object. So a class has no physical existence. It is only when an object is created, the class becomes existential with some properties. So that's all in this video. We have learned about how can we create classes of physical entities, and how can we create objects with them, how can we assign values to those objects, and we can find out the area and achieve various functionality with them. So that's all in this video. I will see you in the next video where we will learn about the 4 principles of object-oriented programming, which is very, very important for the software developers to achieve more productive way of coding. So that's all in this video. I will see you in the next video. Till then, keep learning and keep watching.